Hi there. In this video we are going to discuss integrating dbt with Clickhouse or Clickhouse Cloud. I'm going to spend just a few moments introducing dbt for those who are less familiar with it, and then we're going to quickly get into a demo as to how these two technologies would be integrated. Finally, I'm going to consider if this is a route you should go down, because there are some pros and cons which we are going to discuss. So firstly, what is dbt? Well, it's defined as an open source framework for executing data transformations in a data warehouse. So if you imagine you have a situation where we have some raw data, it's been ingested maybe from a CRM system. And what we want to do is break that down into different tables, maybe clean up the data, transform it to our kind of organizational standards, and maybe pre-aggregate it to make our reporting faster and more performant. That is effectively the role which dbt plays in terms of defining and managing those transformation steps. dbt is much more kind of modern and lightweight than traditional approaches to ETL, where that was often based around kind of heavyweight and expensive and kind of enterprise grade GUI tools where we would define our kind of database loads and transformations. dbt is much more kind of lightweight and accessible and open source, and just generally modernizes the whole approach to ETL, which is why it's become kind of very popular. dbt is based on the idea of models. So if you imagine we have our source data, and what we want to do is define a series of models off the back of that source data. And those models can be chained together. So for instance here, if you imagine we have a table called trips, which is our raw and unprocessed source data. And in the example at the bottom here, what we're doing is creating a model which we are materializing as a table. And we're defining that model in terms of a SQL statement. So here we're looking at the trips and we are ordering by trip distance descending. So we're looking at the kind of longest trips and we're limiting that to 5. And if you imagine what we might want to do is materialize a model called top 5 longest trips. And maybe that would be useful to our business analysts who could just drop that table into their reports and leave it to us as data engineers to manage the materialization of that table. So that's an example, very simple dbt model at the bottom there. What we would next do is a dbt run at the command line. So it's a command line tool. And what that would do is take that model definition, which we've just seen, and materialize it in the database. And you can see with this run, what we've done is materialize 3 models. We have 2 example models, which come with dbt. So my first dbt model and my second dbt model. And the one which we just saw the definition of there, the longest 5 trips. And that has been ran into the database, and that run was successful. Let's briefly consider the advantages of dbt before getting into the demo. So firstly, there are a number of software development lifecycle advantages to what we've just seen. So in the past, people were defining kind of ELT transformations within GUI tools, and that was very hard and not kind of a robust way to develop with. In dbt, what we can do is define our transformations in kind of modular plain text files, which are described as SQL. Those files can be source controlled, so they can be checked into Git. They can be tested both individually and in combination. They can be reused across projects. So it's a much more kind of engineering-like approach to building our data transformations as opposed to clicking around in some GUI tools. The second major set of advantages are around collaboration. So in the past, this ELT tools, ETL tools were managed by a centralized data team, and nobody else had access to them, and they required specialist skills. When using dbt, pretty much anybody can contribute to the development of these models. So that might be data engineers, but also your data analysts and data scientists can get involved in the development and maintenance of these models. And anybody around the business can look into them and understand how are you building these pipelines and the data which you're exposing to the business. The next class of benefits are, what I call DevOps friendly. So these dbt projects, they are very aware of different development, test and production environments, and we can execute against those different environments to test our changes. They can easily be integrated into kind of CI/CD processes. So as you kind of check in your changes, they can be executed against development, test and production. It supports a very nice local developer experience, and we can make our changes locally, commit, send our changes through pull requests, and then have them promoted for test and dev. And again, this is an area where data engineering and traditional approaches to data have been quite weak, and dbt really excels. And finally, all of this kind of combines to give us kind of better data quality and more reliable data delivery, as we may have done in the past. We have this modular approach, we have these different environments, we have things like testing integrated as a first-class citizen. So all of this combines to give us ultimately much better data delivered to our business. So I'm now going to walk through the process of how we would use dbt with Clickhouse Cloud in practice. On the right here, we have our Clickhouse Cloud environment, and we have the typical New York City trips dataset has been loaded. Now what we're going to do is introduce a few transformations for working with that trips data. The first thing we need to do is ensure that dbt is installed on our local machine. And because it's a Python package, we do that using pip, and in my case pip3. So firstly I'm going to say pip3 install dbt, and we can see on my machine it is already there. For you it may go through a process of installing it. And we also need to install a particular driver, in this case pip3 install dbt-ClickHouse. And again, that has completed really quickly for me because the requirement is already satisfied. It will take longer if you don't already have the driver installed. So the first thing we need to do is create a project. And when we create this project, what we are going to do is specify that ClickHouse is the driver behind that project. So I've said dbt init, we've called the project trip transformations, and dbt has said which database would you like to connect, and I've specified one ClickHouse, and that is there because we just installed the dbt-ClickHouse driver. So the next thing we need to configure is the profiles.yaml file, which describes how our dbt connects to our instance of ClickHouse. That information is stored in the .dbt profiles.yaml file. And we can see right now that that is empty. No profiles have been configured. So dbt doesn't know how to connect to our database. What I'm going to do is copy this URL which dbt has suggested to us. And if we navigate there, we can see that initially we see this kind of generic profile.yaml entry. But what we can do is navigate to the page specifically for ClickHouse. And what I'm going to do is copy this template entry, but just the top half or so, because we can accept defaults for the rest. We don't have to set all of those right now. And if we go back into our .dbt profiles.yaml file and paste that template in, what we then need to do is configure this with our actual details, so our actual hostname, username, password, database details and stuff like that for our trips database. So firstly we have to give the profile a name, and this will match the profile name in the project.yaml file. So we'll call that trip transformations. The target is the specific profile which we're going to use, and in this case we'll use dev, which is a convention, but we might also have different targets for dev, test and prod. The type of the database is ClickHouse. The schema is default, because that is where our trips table is stored and where we want to create the new tables. The user is default. I'm going to come back to the password in a second. We are going to use the HTTP driver for this example, but we could connect over the native route if we wished. When we use HTTP port, we're going to go the SSL version, so we're going to connect to 8443, and we have to set secure equals true, and it already was on the example there. So the final two fields we have to set now are the host name and the password. So the host name, I'm going to go to our Clickhouse Cloud deployment and copy it from the connection string, and that will expose the actual host where our Clickhouse Cloud is running. So we can see it's there, it's running on AWS. So we're going to delete this host name and put it in. And then we are also going to copy and paste our password. So I'm going to put our password in the YAML file, but we'll hide that here for the purposes of this video for our own security. Having done that, I'm going to save the profiles.yaml file, and I want to test that dbt can successfully connect to our database. And I do that with the dbt debug command. So what that's going to do is try and form a connection, and we can see here that the connection was okay. The actual check failed because we're not inside the trip transformation project, so no project.yaml file was found. But if I go inside that folder and rerun dbt debug, then all checks have passed, and connectivity between our local dbt and our remote Clickhouse Cloud has passed. So the next thing I want to do is create some models within our Clickhouse Cloud instance. The dbt project which we have just created comes with a few sample models, and these basically don't contain any data. We just have some hard-coded values. So here we have my first dbt model. It contains 2 rows, a 1 and a null, and my second dbt model, which selects from the first dbt model where id equals 1. So this is an example of kind of daisy chaining the models, where the second model is built off the back of the first model. Now if I do a dbt run, what we're going to do is go and materialize those 2 models in our database. So having done that dbt run, that is green. If we go back and refresh the list of tables in Clickhouse Cloud, we can see that my first dbt model has been created, and it has 2 rows, a 1 and a null, as specified in our model definition. And if we go into reviews definitions, then we can see that my second dbt model has been created with just 1 row, because we explicitly selected where id equals 1. So now let's do something more interesting based on our real data. Here we have our trips table, and the trips table contains a trip distance. And if you imagine, it would be useful for us to have a table which always contains the top 5 longest trips, which a business analyst could maybe drop onto a dashboard, or maybe we're always interested in our longest trips in the last day or whatever. So here I'm just going to define a SQL within Clickhouse Cloud, and we say select star from trips, order by trip distance desk, limit 5. And there we have our top 5 longest trips. So my next task is to take that and put it into a dbt model. What I'm going to do is copy my first dbt model into a new model definition called longest 5 trips. So that way, you know, we have the correct structure and the correct kind of ginger and correct layout, etc. I'm then going to replace the hard-coded model definition, which just had that 1 on the null, with the actual SQL which we would like to use. In this case, we're looking at the top 5 longest trips. So I'm going to put that into place, and we're going to clean that up a little bit. And now this model is ready to be executed against our dbt cloud instance. I'm also just going to clean up by deleting these comments at the top and the bottom, just so it's a little bit easier to see what is going on. So now we are going to save that, and I'm going to issue another dbt run. We can see that this time 3 models have been found, so we have those 2 sample models which we've already looked at, and a third model which is the longest 5 trips. Now if I was to refresh my list of tables again, sure enough we can see that the longest 5 trips table has been created, and the IDs correspond between the kind of manual SQL statement which I issued and the data which has been materialized into the table. So that is all as expected. So that is obviously a really short demo, but hopefully that kind of brings to life some of these advantages of dbt as it would be used against Clickhouse. You know, the fact that those model definitions are stored in plain text files and they are defined as SQL hopefully demonstrates how, you know, collaborative and easy to use dbt is. We saw how we defined a dev profile, and we could have created separate profiles for development, test, and production. And what that would have done is enable us to run our transformations against dev, then test, then prod, giving us a kind of nice defined software development lifecycle. If you know anything about things like CI/CD, then hopefully you could kind of see how easy it would be to integrate that stuff with CI/CD. So it could go into your automatic builds, and you can execute tests as part of dbt. So if your tests fail, it could fail to promote to a next environment and stuff like that. And that is because it's a nice, simple, lightweight command line tool, and everything is configured in YAML and SQL, stuff like that. So, and maybe that kind of demonstrated how all of that combines to ultimately giving us better data quality. We also demonstrated there how we would physically go through the process of connecting dbt to ClickHouse. So I hope that demo added value there. Finally, I wanted to spend a few moments considering whether we should actually use dbt against ClickHouse. So why would we do this? What is the case for doing it? I do believe that dbt gives us significant benefits, which we have just discussed, and all of those are true. It gives us a much stronger software development lifecycle. It's easy to automate and put as part of our CI/CD processes. It's very collaborative. Everybody can contribute to it without any dependency on kind of third-party ETL tools, and we don't need to understand those or have access to them. So I really believe in all of those benefits. But specifically about ClickHouse, it's typically used in a different way than we would a traditional data warehouse like Snowflake. For instance, because ClickHouse is very performant, what we might like to do is just query raw, unprocessed data more often than we would in traditional data warehousing. We have less requirement to transform data and break it up into different tables and star schemas and stuff like that in ClickHouse. Because we can lean on its performance, and typically the data that we store in ClickHouse, it's time series based, it's event based, it's sensor data, it's low level, and it's not. You don't have quite so many requirements for highly normalized data warehousing style transformations. The other point I'd make about dbt is it's very batch based, so periodically we would run it, and it would take the last batch of changes and push them into the downstream models. Whereas ClickHouse again is all about performance, so a better way might be to define a series of materialized views which process data as it comes in, because ClickHouse materialized views are very powerful, and for me one of the main reasons to use ClickHouse. I would also say that dbt is not without its critics. It can lead to what we call model sprawl, so people create lots and lots of models for each step of a process, and they can be heavily kind of chained together in a complex network, and that can lead to a lot of work to simply keep those models up to date. And some people say, is that even a worthwhile exercise when we have these kind of powerful data warehouses and we don't need all of those kind of levels of abstraction in terms of how we build our data pipelines. So for me, it's kind of a question of trade-offs. If you really value the software development lifecycle benefits of dbt, and if you are working with data sets which are a little bit more kind of data warehouse type of nature, where we do want to break up source data into multiple tables and give our data analysts a nice views into that data, then maybe it is worth adopting dbt and using that against your ClickHouse instance and enjoy the benefits of that. If you are working with kind of low-level data where latency is important to you, and you just want to query relatively raw and unprocessed data and lean on the power of ClickHouse, then I think to introduce dbt would probably be the wrong solution for you, because it would turn your whole system into batch. So there's no right and wrong answer, but that is our experience. On some projects, where latency hasn't been critical and where we've needed a lot of processing into intermediate tables, we have gone down the dbt route and been successful with it. In others, we lean more on the native features of ClickHouse and simply define our models as materialized views. I have a few blog posts we've written on this topic. One considering the kind of benefits of DBT more generally, and then delving into this question as to whether or not we should combine with ClickHouse. So kind of repeating what I've been saying here with a little bit more depth. And we also describe a real project here, which we did in the crypto space, which involved combining DBT with ClickHouse, and that was very successful for the purposes of that specific project. So I'll leave it here. If you are interested in building solutions on ClickHouse with or without DBT, please do reach out to us for an informal conversation. We specialize in this space. We love building applications in ClickHouse, and we'd love to hear what people are building with it. So thank you very much.